Right. So, welcome to the Operating Systems Day School. This is a level 4 day school for the BSc degree program. Course codes are CSU 4300, CSU 5315. And this particular course is one of the 4 courses offered by the Department of Computer Science for the BSc degree program for the level 4. So this time I got a list of 500 students. So I don't know whether they would actually register for the subject at the upcoming registration. Anyway, the Zoom link only has the capability of 300 participants. So if it overflows, I will try to broadcast this day school over the YouTube if that situation arises. Okay, then anybody, who miss the day school, not actually missing, they cannot participate through the Zoom, can always join through the YouTube link. So still only 130 students have joined. So we will see how it goes. Okay, so let me brief you about this particular course. I think I have sent you course material, first 12 lessons, the Google Drive link. So hopefully you can access all those. Has anybody tried viewing the course material?
Yes, sir.
Yes, can you see it? See it? Open
Yes,
it?
yes, sir.
Okay, then everybody should be able to open the course material. So until such a time that your registrations been done and get the physical copies, so you can use this soft copy for your studies. So I know some people find it very hard to read it over the phone, so through the desktop. So please be patient with us, and we will try to make sure that everybody gets the course material. And operating systems is not a difficult course. However, it has a lot of theoretical components. And there are a lot of working examples of the working, the workout questions, so that you can get a better grade for this course by studying it methodically, one day school at a time. So I will try to cover, about 3 to 4 sessions, sometimes about 5 sessions in a day school. So certain things which are really important will only be mentioned at the day school. So don't expect me to spoon feed you everything that is there in the course material. So it's up to you to read the course material carefully and understand the things, ask me questions in the day school itself, or else you can, I have sent you the Telegram group also. Please register in that. You can work on the questions, the past papers and everything, and take a photograph and put it on the Telegram group and have a nice discussion. So I don't mind you, discussing each other in the Telegram group itself, and that is how the other past batches have got good grades for this course. So don't ask that, only putting up the question, okay, does anybody know the answer? It's not the way. You watch the day schools, work out the question, then put with the answer you got. Then others can respond easily. You have this particular problem, there you have this particular problem and all, and help each other. So there is no competition in the degree program to, so that if you help somebody, then you don't have to study, because when you help somebody, it will go into your permanent memory, and actually then that will help you to uh, do less studying, less cramming up near the exams. So then about the course structure, two NBTs are there for this course, and final examination is 2 hours, NBT is 1 hour. So about 5-day schools are there, but if we complete the content in 4-day schools, the 5th one will be cancelled. So hopefully, I think it will definitely go over 5-day schools. And first 12 lessons are coming, I mean, are for the NBT 1, 13 to 25 for the NBT 2. So please don't send me emails asking what are the sessions that are coming for the exam and all. Generally, I will set the questions from entire area. So, right? So, and please make sure that you rename your whatever the display name of the Zoom uh, with your registration number, so that I can get the Zoom report for the attendance, right? And the name is also okay after the registration number. So then I can get the Zoom attendance. So you don't have to type it one after another. Um, about the attendance. So if you do the rename it properly, then it would be a help for me. Yes. So and the next thing is uh, now the Moodle course enrollment key. This is not needed because it will be automatically uh, enrolled. I mean, you will be automatically enrolled for the Moodle course after you register only. So uh, until such time, there will be no Moodle course for this particular subject. So let's start the introduction. So some of you, this course will be little bit boring because if you know little bit of hardware and if you are involved in the computing jobs, of course, certain things which are said in these day schools are sort of, you know it day to day. But for others, of course, there are few things that you need to know. What how these computer system are built upon. So basically, it has three major areas. One is sort of hardware, which provides basic computing resources. For example, CPU is called central processing unit, the processor, and then the memory of the computer, which is called RAM. And almost all of you have learned this in the level 3. However, it's my duty to, I mean, brief you on the things you have. Then you have input output devices connected to it, and all those electronic components, including the monitor, the other stuff like mouse, keyboard, and all, are mm, uh, comprising of the hardware of the computer system. Then, uh, in order to, I mean, connect all together and get some meaningful work, the operating system has came up. Uh, so in these days, of course, there are no computers without operating system. But in good old days, there was not like that. So there were computers without operating systems. Only after 1950s only there were little bit of this operating system concept came up, and uh, where it oversees connecting all the hardware and provide a user interface for other stuff. I mean, for the users to act upon, for other devices to act upon, and so on. So then the operating system actually does some uh, controlling of the hardware. based on the request you give. So these requests can be coming from the application programs. So this how the system resources and other things are used. So these system resources, sort of like printers, and the communication devices like modems and all. So uh, in order to utilize all those, we have certain programs. We call them application programs. And generally, most of you may have used so Microsoft Word or Abbey Word or uh, likewise word processor system. Whether it can be a Linux system or can be a Windows system. The word processor is a program, application program that can be used to um, give out, do the document preparation. So then you have programming languages where your programs are being designed, developed. So the compilers are there in order to, convert your program code into binary code, which can be run on a computer. So in certain programs that you do in C, C++ and all, you can create executable file which can run on a computer. So in Java programs, you create object files, and for the Linux systems also you can create object files and the executable files, which can be run on those operating systems. Then you have web browsers where you access internet, you do all sort of things, and even application programs now run on web browsers. So you have the web-based interface for most of the work. And then I think you have learned in your uh, level 3, the database management systems. Uh, and all those things can be hosted or installed in the machines and servers where this operating system supports handling of resources through the CPU, so the RAM and the hard disks and all, in order to run your programs. So which database management systems that you have learned in the level 3? What is the database management system? Level 3? Which one you
SQL.
huh?
Yes.
Yeah, I couldn't get the name. Yes.
MySQL.
MySQL. Yes. So actually now this MySQL is the database management system that you have learned at level 3. But for that MySQL, you need to have a um, structured way of issuing these different what to call uh, different output from the database that you have. So for that you had a language called query language. So we have learned SQL. So this SQL, there are two types actually, DDL and DML. So DDL means when you are creating certain tables and certain stuff, we data definition language. So we use SQL for that data definition commands and all. And then when you are selecting, updating all those stuff, then you use DML, that is data manipulation uh, part. So for that you have different SQL commands. The nice thing is most of these SQL commands are based on a particular standard. So if you issue the standard SQL commands in a different database management system other than MySQL, it's still gonna work because that is based on a standard SQL standard, and even in Oracle, some of the standard SQL system works. Because of that, when you learn the DBMS, it is not just MySQL. You learn a global, the universal uh, database query, database query system, query language, where you can use to obtain the results, manipulate the data, create tables and all. So it is very important that you have that knowledge intact with you when you are going through this degree program, so that in future, if you decided to go on an IT related job, this knowledge is pretty much essential. So then we have other application programs like movie players, video games, and all. So actually, there are a lot of applications which run on top of an operating system. So the fourth component is users. So users can be people like us, or it can be other computers, or it can be specialized machines, uh, like manufacturing or sewing machines and all. Even televisions can be connected to computers these days. So that's about an overview of a computer system. So let's come back to a operating system. So there are a lot of theoretical component they are given in the book. So you have to read them all. However, now I will brief you on this. Uh, yes, please mute. So somebody talking.
Oh, sorry, Gopal.
Right. So the uh, right. So operating system basically makes hardware usable. All the resources in a PC are keeping track, manage and allocated resources efficiently, because most of the programs actually needs memory, hard disk space, CPU time to work on. So keeping track of them and managing them is a task of operating system. And then uh, finally, provide wide range of functions to assist processing and execution of a program. So uh, actually, the thing is, now this operating system actually it's like sort of a big brother to all of your programs, where it gives you resources, right, to work on. So this, in order to have this work, there is a special program which runs on the operating system at always when you start a computer. It is called kernel. So this kernel is a control program, and it has access to all the hardware resources, RAM, printers, USB drives, everything, right? So it has authority to run all the hardware instructions as well, because every hardware device like your pen drive, printer, and all other hardware has a specialized way of accepting commands. So all those commands uh, are compiled into a particular program called device driver. So when you install a driver software into this particular operating system, then kernel get to know through the driver, okay, which way this hardware operates in. For example, if you take a printer, so what is the command to give in order to move the printer head from left to right? So that is included under the driver program, and kernel has access to the driver program, and through the kernel we can control the printer head. So likewise, this kernel is sort of a control program where it operates all the time in the operating system. When it is started, has access to the old hardware. We call it this the state of this particular kernel is called, it is running on the privileged state, that it has superpowers to do anything, right? Then the other programs, they cannot directly address the hardware, they does is they ask from the kernel, okay, I want to do this, I want to do that, and all. Then kernel facilitates if it is a valid thing. For example, your printer only can print A4 paper, right, in A4 paper, but use in a particular Word document also maybe on A3 paper size, right? So then if the direct word processor directly send the command to print, then the printer head will move to the left or right, and where it will go and damage itself because it doesn't have that width and or length. So the width is the problem. So the kernel actually do the safe operation. So safe operation where those controlled hardware is running safely within the limits of operation. So lot of things happening in the kernel. So next thing is that there are two kinds of kernels in a operating system. Based on the operating system type, for example, you have Windows family of operating systems, you have Linux family of operating systems, and you have various other uh, operating systems, small ones, Android, and for the mobile operating systems, iPads, where all kinds of operating systems. So there are two major kernel types. One is called macro kernel, the other one is called microkernel, right? So the macro kernel actually is little bit macro is the name itself says it is a big, right? So the macro kernel is little bit of a larger size, where all these device drivers and various other essential components are built into the kernel itself. So it's like a big ball where inside that you have small driving components and all. So there is a outer cover, something like this, to protect it. So if the everything is built onto the kernel, it is very difficult for viruses and various other malicious programs which attacks the computers to get in, because it protects everything and it has all built in. So no external software connected at the time. So then it is very difficult for the viruses to penetrate macro kernels. So that is why the operating systems which runs macro kernels are little bit protected from the computer viruses and the malicious programs out there. Generally, the Linux systems, Unix systems are based on the macro kernel. So because of that, Linux systems are more secure than the Windows systems, where it has the other type of kernel, we call it microkernel. So microkernel is the file size and the program size is little bit smaller than the macro kernel, and it only has the very essential small components that need to run the hardware resources, but all other things like device drivers, various other aspects are outside the kernel. So they will be, communicated only when necessary. So that is because of that microkernel size is small, and because of the drivers and other software essential parts are outside, sometimes the computer viruses, worms and stuff are can attack those drivers and do malicious things. So that is why for Windows systems we always need a virus guard active in order to protect yourself from the viruses, worms, and various malicious programs coming on the way, because they can, actually attack these different drivers and other system programs. So that's the difference. So if I ask a question at the exam, what is the difference, main difference of between two kernel types, macrokernel and microkernel, then you should be able to summarize all the things that I have said in a one sentence or two, and then I mean you can get the full marks. So this kind of questions I will ask. It is not directly the theory that you have to come up with a constructive answer, right, at the exam, right? If you cram everything and you even write paragraphs by paragraphs, sometimes you won't get the full marks. Sometimes one of your friends might give you the exact answer in 2 or 3 words, then he might get full marks. Then you might later complain to me, sir, I have written say 20 pages, still I got C, where your friend only have written maybe 3 to 4 pages, but he got A, right? So that is why I'm telling you this particular subject, you have to read, understand, and summarize. What are the things that is really important? And when you are writing the answers, be precise. Okay? And it doesn't mean that at the exam you don't write a thing, right? Sometimes some people do like that. They write only the things that they know, others they keep it blank. So, but they have, if you have, say, a rough idea on what are those, but you cannot exactly remember, still try to, write something. Then I will consider when I'm reading whether this person has uh, understood the problem, but they cannot, give the precise answer. Still, I might give you some marks. So, because language is, for some people, language is difficult, right? I am doing this day school in simple English. Sometimes some people might find it hard to understand even that simple English. So what to do, right? So this is not an English exam. So because of that, you try to, put your thoughts in English as much as possible, and we will try to accommodate. Okay, so then this is basically abstraction of system components. You start from the user, then the user interacts with the application software. That is normal software that we use every day, word processors, Excel, PowerPoint, even music programs, games and all. Then the application software access the API, we call it application programming interface, because there are libraries which is provided by the operating system and the application developer in order to access those functions. So the API is the middle man which act between system libraries and the program. So then you have system libraries, then you have operating system interfaces where operating system level libraries are there. So this part, operating system interface, is actually developed by the operating system vendor, where API may be developed by the application software itself. Now, for example, these days I am working on developing a program which utilize API, application programming interface, of Microsoft Word, right? Uh, I am amazed by the features provided by the API of Microsoft Word, where you can control MS Word from your computer program, anything. From the simple typing of the letters to the formatting and everything, without actually typing in the Word itself, you can control the Microsoft Word through a program where you can do bullets, numbering, bold, underline, pagination, page setup, section break. Everything can be done through the programs. So that is sort of an application programming interface provided by the software vendor. So, that is why I am telling you that it is very nice if you know some theory that can be put on to action for the real world. So that is why I'm taking real world examples when we move on, to match the theoretical components with the real world, so that you don't have to cram everything at the end of the class. You can simply remember it, because with the examples you learn. Then you have operating system interface, operating system, and then the hardware interfaces of these different uh, hardware you have attached. So because every RAM, every CPU, every other device like printers, all other things have a device driver. So those device drivers work on the hardware interface side. Then you have hardware. So this is sort of a complete abstraction of a computer system components where there are different shared resources like hardware and operating system, uh, which is utilized by the operating system to provide you with a nice experience. So now I am moving on. So there are objectives and strategies of operating systems. There are, I mean, sessions on this. So the objective of the operating system is hide the details of hardware by creating abstraction. For example, if you try to write a software, right? If you try to write a software uh, in order to print something, right? Uh, there are, I mean, thousands of printer models which you have out there in the market. So without operating system, if you try to directly address, directly print into those printers, I mean, your software has to be so big that you have to, use the different instructions for each and every different printer, right? So in order to avoid those, you have standard instructions of print, okay? Print page number 1 like this. Then operating system has all sort of drivers for those printers, and when you buy one, you get a driver CD, or you can download and install in the internet. So when you install the driver software, operating system take care of the internal commanding structure. So the program only has to tell the operating system, I want to print this. These are the text. Okay, this is the page setup and all. Then operating system takes care of it. So then that is the first part. So that is hiding the cumbersome details of the hardware by creating abstraction. So you only tell what to do and you don't tell how it is being done. So that is handled by the operating system. Then allocate resources to the processors. So this is very important because in good old days, one program ran at computers at a time. So the second program can run only after the first program has finished running. So this created a lot of problem because you have the hardware which can run multiple programs, but the way that the program are structured, you can only run one program at a time. So this has changed over the course of the years. Now it has came up a technique with the uh, came up with the technique to run multiple programs at the same time. So I will explain when you learn this course further, you know how it is done. So when those programs, multiple programs are running on the computer, so you need to allocate resources. The main thing is to allocate the CPU time, then allocate the RAM because some programs need memory space. We call it memory, primary memory to run, and the hard disk space and all. So this allocation part is handled by the operating system. So you don't have to care about it because OS does it. Then provide worthwhile effective user interface. So you get nice user interface, themes and all those things in modern operating system. So that is for the user convenience. So the having an operating system has these objectives, right? Then there are different strategies of operating system because operating systems are designed for different purposes. So good old days we had batch operating system. So yes, like this. So we had batch operating system where you input your data through a card reader or a tape drive, and then those tape drives will be fed into uh, the system where it does run the program and write the output into a different tape, and then this tape drive will be put into a printer where the output is printed, right? So then when you have do some input or your program, it all that happens sequentially, right? After running entire thing only you get an output or a error sheet, right? So because of that, um, uh, sometimes in good old days, I remember our teachers were saying that, okay, I did computer programs. I write and punch it, the punch card system. There is a special typewriter to punch it. So I written the program in the card system and give it to the computer room at the end of the evening. And then they run it overnight. Then when I go in the morning, I get a report. Then I will inspect the report whether I have made the mistakes. Then only I again change the cards during the daytime, and at the evening I will give that another program, the changes to the computer operators, and then they will run the program. That is how the old programs ran. So they ran one after another. So this is called batch system, right? Then came time sharing system. So they have found that, okay, batch operating systems are very hard to run by because there are so many requirements to do. Then the later came up, the speeds of the computers have increased. So then they came up time sharing system. So the concept of time sharing is this. Now, supposing you have a friend which can, do some important work, right? Then now you want to get something done. So you go and talk to him, okay, I want this to be done. Then another about 10 people come and ask that guy the same time. So they will take all their jobs, this particular guy, and he can do either sequentially. That means one after another job he can do, or else what he can do is do a part of person 1, part of person 2, part of person 3, and so on, and parallelly doing everything, but only part by part. So 1 to 2, say supposing the day's time is divided into 8 hours. So okay, 8 to 9 I will do persons 1's work, 9 to 10 I will do persons 2's work, and likewise you do the time sharing. So in the modern operating systems, when the speed of processors are so high that you don't feel that this particular task processors works in a time sharing manner. That is, CPU time is given to that program, this program, and so on. And CPU is so fast that we feel that everything is happening at the same time, but actually in the real state, the programs works one after another, right? Because of the speed, we feel that we get the illusion that everything is done parallelly. Okay, so that is what you call time sharing system. Then the third one is called workstations. Actually, this workstation concept is bit old now, but for the clarity we give, so we will help the workstations are sort of when you have this expensive hardware, what you do is you try to share those expensive hardware across multiple not that complicated computers like terminals, where it may not have these hard disks and so on, only connecting to the workstation. So workstations are computers which can run programs fast and provide interfaces for the multiple users working at the same time. So that concept is being used still at some places, but these days, of course, workstation concept has gone out and the server and the client concept has come up. So the final strategy is sort of real-time systems where you have a finite time for a producing output. For example, so the aircraft control system or a nuclear fusion system. So the systems can't simply hang, right? Because now planes are flying and the collision detection system, aircraft collision detection system and various other traffic control has to work and have to give output within the given number of milliseconds, right? So if it is not there, then the planes or the accidents can happen. So that sort of strategies are there in the real-time systems, and those are very well, I mean, quality controlled to provide the output at the given time. And they have limited input and limited output for the specialized work. So these are the 4 different strategies of operating systems. And I will let you now read the historical things, right? Early computers did not have operating systems. Even the program languages were not there. Then the General Motors research laboratories introduced the first OS for the IBM 701. Then I told you about the batch jobs. Then the concept of multi-programming, which is time sharing the CPU time, came up to improve the memory and input-output utilization. Then for the uh, most difficult problem was handling the input-output devices like printers. Then when somebody is ready to print, then they can put that job in a special area called spool. So when that printer finishes one job, they can run the next job in the queue. So the programs can put their output requirement in a place called spool, and then the printers can access the spool component and get the job, and it can run. So the programs can continue because they have already finished their work and put the job in the spool, and the printer can operate at its own speed because it has always has jobs to be printed. So this the simultaneous peripheral operation online, sort of the spooling concept, was introduced in order to uh, match the speeds of the fast executing programs and slow input output devices. Right. So the that was about the history. So I explained this, how the jobs are being done, and even different memory areas can be allocated. Then we have this operating system components. Remember that now this every operating system is can be Linux, it can be Windows, it can be mobile, it can be even television, right? It can also have an operating system. So all those operating systems have, I mean, mostly these components, mostly have these different components, because there are certain programs running, and the jobs created by those programs are called processors. So those processors has to be managed. When those processors are running in the CPU, when those processors are waiting for something, when those processors are accessing the disk, and all those things has to be managed. And we have to keep track of which process is completed. So those jobs, we call it process management. Then you have certain limited amount of memory in the device or a computer. So not all programs can be loaded at the same time. So because of that, the memory, the RAM space has to be managed. We call it main memory management. Then the writing the outputs or reading input from the files, those things has to be they are the file management, the naming convention, the allocation convention, how those things are there, I mean writing and reading, the technique. So Those are called file management component. Then the actual operations of input output, like displaying it in screen, or send it over network line, or send it over the internet, or print it in the printer. All those things are handled by the input output management. Then the next thing is the storage. So the storage can be in different types. Some are sort of you write it on the CD, some are on the DVD, some are on the pen drive, right? There are hard disks. Hard disks are different types. Like you have this magnetic hard disk, and you have SSDs, solid state drives. And the way that you store the data in a secondary storage is called secondary storage management. The secondary storage means it is not in the primary memory. It is stored somewhere in a disk, or the pen drive, or a CD or DVD, or somewhere which can be accessed later, right? So give me a second, please. Sorry about the interruption. Can all of you hear me? Hello,
Yes,
can
sir.
all? Yes, okay. So then I was discussing about the secondary storage management. So then we have networking, where you have to send the data over the communication channels. Then you have the protection system, where when multiple programs are running, so you have to protect the storage space, memory space of different programs, and because one program cannot access the memory area of another, so you have to keep track of all the different areas. Then that is called protection system. Then you have a command interpreter, where the certain commands can be given over the console, not using the mouse and various visual devices, but you can directly type the commands. So all those stuff is handled by the command interpreter. So this kind of, I mean, arrangement uh, are there in the operating system. So in next few sessions and in the book, we learn about these different management components, right? So it does mean that if you are very good at process management, so you can score there at the exam. So you can work on the questions, you can work on the theoretical components if you study well. So if there are questions in that part, you can easily score more marks, right? Likewise, there are different areas where certain parts are little bit difficult to study than the other parts. So pick your parts and do the past papers. And there is no guarantee that I will ask the same question on the next finals, but sometimes I will like to keep the structure of the paper, but it can change. So please don't blame me at the end that okay, this year the structure change, this year the questions change. And if you study well and if you understand the concept, you should be able to answer any questions that I put in your way. Okay? So last year past paper එකේ තිබුණේ මෙහෙමයි. But this year that is not there at all. So you have changed the question. So don't come and tell me like that, right? So I don't entertain that sort of any complaint because I want you to study. I want you to do it by understanding the concept. Okay, not just cram and just changing the values and all. So I don't do that. Okay. Then we have these different operating system function. So basically, we look at a world in our own way. Everybody do like that, right? In an operating system also, there are different views like that. The way that operating system is seen by a computer programmer, right? Or the way that operating system is seen by the systems side, likewise. So first of all, we'll learn about the programmer's view, right? So for the program execution, the OS provides environment for user programs to run, right? So it does have the memory, so you only have to request it, right? So the operating system provides environment where user can conveniently run programs. So you have this particular developer interfaces. So in your first year, what is the software that the development program interface that you have used for the programming, right? In the first year, what is the programming language you have learned?
C program.
C programming. Okay, what is the interface software that you have used?
Code blocks.
Code blocks, correct.
Code
So,
blocks.
yes, operating system provides a way to install code blocks, right? Simply you write your programming logic, right? Then codes blocks runs it for you, right? Then the when you display something, when you display certain things as output, so the output is nicely formatted and shown it to you, right? So this operating system provides the functions to the code blocks in order to display them. So you don't you only give the issue the command like printf or something, right? So then the output will be displayed. So that is what we call, and the programming execution, the operating system provides you the environment. Then for the programmer, IO operations. I have reiterated this several times. Each program requires input output, so it can be handled by the OS. Then if you want to save something through your program, you simply issue the commands to write the file, read the file, and so on. So the file system manipulation, the rest of the things handled by the OS. So those management services we utilize through our programming interface. Then communications also. Supposing that you are programming say chatbot or something, where you can chat with your colleague at the other computer, right? The communication. So when you send some commands, the communication should happen from this computer to the other computer. So it might be identified by a computer address or computer's IP address or some kind of a mechanism. So these communications has to be handled by the operating system. Then when you are writing a program, most of the time what we do is programming mistakes. And even the very well running program, sometimes if you give a wrong input, there can be errors. So those things has to be handled. So the system cannot crash, simply like that, right? Even though you give wrong instructions, even the wrong input is given, the system cannot crash based on the wrong instructions. The systems has to handle that the wrong input and give an error message to the user saying that, okay, you are trying to do this thing, but it cannot be allowed, or this error has occurred, and the operating system has to continue. So those things which is very well needed by a programmer when they are writing the program they are handled by the operating system. That is what we call programmer's view of the operating system. Then the system's view is how the OS looks at the currently running programs. So operating system actually see whether has maintains the charts when you try to allocate memory, when you try to access the disk and on, whether the others are using the disk, whether you have enough RAM space for you to allocate for the program and so on. So those allocation of available resources is very important in the multi-programming environment where multiple tasks are running at the same time. So this is handled by the OS because programs itself doesn't know what are the memory amount allocated to the program B, program A doesn't know. So program A only can request from the operating system, I need this much of resources, can you allocate me? හරි ඕක හරියට මේ ගෙදර හම්බ කරන්නේ තාත්තා මේ තාත්තගෙන් සල්ලි ඉල්ල ගන්නවා වගේ වැඩක් right there are so many people which doesn't understand Sinhala, so I will repeat that in English, right? Now supposing I want some money to do something, the only father earns the money, so every time we want to make a spend, we have to ask it from the father, right? Likewise, programs ask it from the operating system. So the allocation, resource allocation is handled by the OS. Second thing is usage details, right? So the usage details are the how many, okay, this much of RAM, this much of hard disk space given to this particular program, and sort of keeping track on what has given, what has released. That guy has finished the work, so he has returned the memory back to the operating system. So likewise, those usage has to be tracked. Then the security and the protection means if multiple programs are running, right, one program's memory request and the writing to the memory cannot be, interfered with the other programs. So the OS has a responsibility to manage all those. For example, now if the computer virus is trying to access the most important program, so then the OS has to protect it. So it should not allow the computer virus to, create a problem in a good, well running program and do malicious changes to the program. Malicious means the unwanted changes. So when the many users competing for the resources, they have to protect the programs from accessing each other's memory areas and the data from other programs and so on. So, and sometimes it needs the security of who can access what program. Likewise, security when multiple programs are installed and running in the computer. Okay. Then you have system calls. So system calls are sort of high level instructions which can access different hardware or privilege work. So generally the user programs doesn't have access to the internal hardware instructions. So what they do is they try to access those hardware using a system called sort of programming interfaces provided by the kernel. So these system calls are generally developed through the high-level languages like C and C++, and Windows have a set of system calls provided by Win32 application programming interface. That means if we can't do it ourselves, we ask somebody who can, like that, right? So there is a guy who can, do the manipulation of computing resources. We call it operating system. And that guy has given a list of commands for us to utilize. Okay, we issue that command to that particular guy, then he will take care of doing the operation. So that are called system calls, where the user level processors like our programs can access high level work, high level services, communication services, printing services, memory allocation services, when it is really needed for us to work on. System programs actually provide basic functions to the users, so they don't have to write their own. For example, saving files, running programs, and getting the amount of memory which is there, and the file modifications, the developer API, and communications. All those things can be built on to the programming language itself, or else provided as a library. So the user programs only have to utilize them. They don't have to write it from the scratch. So it is like now now program, if it is a program, is like inventing a wheel. So it is very difficult. So wheels are there now. We only have to use it, right? So these days what we do is that. So the good old days, people have developed those libraries. So we are only using them today. Right. So with that, I have completed the introduction section, right? Do you have any questions? You can ask me now. Do you have any questions? So shall we continue?
Okay.
Okay. So then it's like doctor's prescription. So what you do is I'm talking and you are listening. And if you have this note management tool, try to make notes there, even in your piece of paper. And the people who have the good old students of mine have always told me that when you teach, we love to take the important notes down, maybe either electronically or in the piece of paper, so that when we listen to the recording later, then we exactly remember what are the things that we have discussed. Okay, so let's discuss about the process concept, right? So process is a small task given to the maybe running on operating system. So it is a prime element used in computation. So it can be utilizing a CPU for a certain small task, right? When running a user program, computer can also be reading from the disk and output text to a screen or printer. So in a multi-programming environment, this CPU plays a key role of switching between different tasks. We call it processes, right? So the CPU responds to the request for input and output, and when there is error, they stop running the program and allow errors to be uh, displayed to the user or output to a file. So the process management actually referring to the services provided by the operating system to support the entire this running and management of a collection of processes in an order, right? So you have for example, if you plan a party, so there are things that need to be done, right? So first of all, you need to have a number of people you expect to put it, I mean, get the involvement in the party, right? Then there has to be an organization committee. There has to be a list of things that have to be done. So each task have to be delegated to somebody in the organization committee. So likewise, you have a list of tasks to be running. So which task runs first, which task runs in parallel, which task runs once after another, which task is delegated to some other place or get an outside service. All those things has to be managed by you. in an operating system also, in a process, there are different tasks. So it has to be managed, and those management job and which order it runs is managed by the process management. Because CPU is running only one program at a time, giving users an idea of a parallelism because it is completing the tasks one after another in a quick succession. We change the tasks. We do part of that, part of this, and part of next, and so on. It just doing it quickly so that we think that everything is happening at the same time. So a process, the definition of a process can be a program in execution, a program that is running, say word processor, your developer program, your music program, and so on. Then it can be an asynchronous activity. Likewise, while you do the typing, the spell checker works, right? The focus of control of a procedure in execution. So that is when you are running a computer program, so certain parts are running, doing the computing, the adding something or doing a multiple complex operation. So the place of control, that particular process which is running to the computation can be a process. So, and any process which is running in a computer has to have a place where its name, what are the things that is it requires, how many memory handles, how many memory areas needed, how many files are open. All those things has to be mentioned in a special area called process control block. So the process has to be defined, and those information of the process has to be stored in a process control block. And an entity which a processor is assigned is again can be called a process. So these are different definitions for a process. And in a dispatchable unit of a program, that means if you have a computer program, entire program does not run. Only a particular part of program does run. Others can be definitions, memory allocations, everything is there, but only the running part, computational part, is called a dispatchable unit. So those parts has to be there. So this can be called a process. So program you write is a passive entity which has a set of instructions. When it runs on the CPU, it is called active entity, right? So these definitions are important. So now then we will learn about programmer's view. So the process, actually then you can schedule it. Okay, you have to run it now or you can run it later. So it requires certain resources. So process can be created, process can be terminated, or process can be suspended, or process can be resumed. So it is very important. Likewise, now for example, if you take a photocopier machine, so photocopying job can be like a process. So you can start copying, you can stop copying, or when some higher priority jobs comes, you can suspend your photocopying work and let the other small job to run, or you can resume. Okay, now that job is finished, then you can resume the photocopying. Likewise, the process can be created, or it can be terminated, it can be suspended, or it can be resumed, right? Then if it is a process, you can change the priority. Okay, nobody can interrupt this particular process. So that is sort of the priority of the process. So if it is a low priority, anybody who is coming with a short work can override this long running job maybe. So then you can block the process and you can wait for something to happen and then wake up. Okay, you can sleep and wake up and you can dispatch means you can let the process to run on the CPU. Then different processes are there which needs coordination. We call it inter-process communication. For example, if you are organizing a certain event or a party, right? Event manager uh, assigns tasks for you. Likewise, ordering the chairs and things handled by one person, where ordering food can be handled by another person. But you need to have a proper coordination on when to bring those chairs and tables in. Then you might have the food ordering guy. Okay, when you are expecting to deliver this, because I need to have a mechanism to store all those. Okay, arrange the chair before that. Likewise, so the inter-process communication is important, right? So when you are running programs in a computer. So when you are creating a process, so there are several operations involved. First one is naming the process. Second one is insert the process in the list of processes that are running, and that are, actually exist in the system. Uh, okay, which priority for this particular process has. Then you have to have that PCB. We call it process control block, where a small data structure of the details of the process. Then finally, the allocate processors initial resources. Okay, how much memory? Okay, 10 MB or 20 MB. How many memory blocks needed, and how many files that needs to be opened. Likewise, then parent and child processes are there, where one process can create another process. So the one that creates a process is called parent. One that is created by the process is called child. So sometimes you can create processes, parent and child run independently, even though parent creates a child. Sometimes they are dependent. When the parent is terminated, all children has to be terminated. Likewise. Right. Then we have a process model. So all runnable Proftea is organized into a number of sequential processes. So each process has a program, input, output, and a state. So let's see how these processes are created, right? So if you turn on a computer, what happens? So forget about the process. When you turn on your computer or laptop or whatever, what is happening first? When you press the power button, what is happening? Do you know anything? Somebody answer me, please. When you press the power button of the computer, what are the things happening?
The screen is appearing, sir.
Yes, screen is appearing. Okay. When the screening has turned on, what are the things it is displaying?
The icons that we use.
Just before that, just turned on. So what are the things that generally appear? Yeah, it displays some logo or a brand, then it counts memory sometimes, right? Uh, Sometimes it displays, okay, so this much of memory is there, this is the CPU speed and all. Then it suddenly starts displaying the operating system logo and all, then comes to the login of the logo. Yes, logo of the operating system, it will come, right? So then comes back to the interface. Actually, what happens is when you turn on the computer, first thing it happens is it will read the basic input-output system, that is BIOS of the computer, and it checks whether all the internal component connected to the computer, which is listed under the what you call the BIOS, are connected and works. So it checks itself, right? Then after that, it will check whether there is a operating system present. Then it will try to boot into that particular operating system, load it into the memory. Right? When it is there and it is properly working, it does reads the everything into the computer's memory, and it creates several processes like reading files, writing files, memory management, loading the kernel, everything, right? Then only it displays you the user interface to log in, right? So by that time, a lot of processors has been created by the operating system and running on the computer, right? So when you create when these processors are created, when we learn that, first thing is when you initialize the system, like booting the computer up, processors are created. So that is what is mentioned in this slide. When are the events that create a process? So first thing is initialization of the system, right? When you boot the system. Then if a running process executes a process creation call, right? So then one process runs and it needs to do some tasks. So it might create another process. Then a user program or process request to create a new process. And when there's a batch job is initiated, several tasks will be initiated. So these are the 4 instances where when a process is created. Okay. So irrespective of the place where it is created, after it is created, you need to have a proper PCB, that is process control block, created, and based on that, we track down what are the processes in the particular computer running, right? Some people are asking for the recording. So I can decide whether to give it or not, but I am giving it anyway, right? I'm recording it, so I'm giving the day school recording. But yeah, if you can, of course, listen to me, would be ideal. However, it doesn't matter. So some people are at work, so I know that during the daytime. So I will give the recording. Okay. So there are 2 kinds of processors that can be in an operating system. Foreground processors, which is running, interact with the users, and background processors, it is always runs in the background, but it does have some functions, for example, virus guards and so on. So, and these are the 2 commands that creates the process. Fork command is used to create processors in Unix, and create process command in Windows are the system calls that used to create the processors. You know, this is particular examination question. Sometimes even a simple question like this are not answered. So, I mean, it is particularly sad because some people fail this subject because they don't, I mean, even simply read the slides, right? So, forget about the book. They don't even read the slides even, right? So, I mean, that is very pathetic sometimes. So don't expect me to give you free marks. I am not giving any free marks unless you write, uh, you um, you will you won't get any marks from me, free marks, no, right? And some people are asking whether how can we get the past papers. Open University has a in library past paper archive system, PQP. So you can search for the course code and you can get the past papers from there. And when the system, this LMS is up, I have published several past papers, CATs and final in the LMS, the course, Moodle course itself, so that you can download it from there also, right? So don't worry, I will give all the resources. Only thing is you have to study and do well. That is what I expect. Okay. So how a process is terminated. So that is another thing that we need to do. Process will terminate. It can be either normally or abnormally. So the normal processing means after it does its task, it can do a normal exit. So it just finishes, right? Then when there is a error, uh, which it cannot continue, then it can be terminated. So it's a simple error which is known previously, right? Then, or it can be aborted by a based on the input. So then when it comes to a fatal error, that means unhandled error can come because of maybe the errors are not handled by the program properly. For example, if the abnormal input, like when you need a text, you input a number. Likewise, the wrong input is given. If it is not handled properly by the program, then system may crash, the process may crash. We call it fatal error. So that means it cannot continue at all. So the process can be terminated, or else killed by another user or another process, right? So now sometimes certain processes we don't need, so we will simply terminate it by the task manager. So you can, every computer now Windows has a task manager, so you can go to the task manager and select the process, and then you can end process. So this sometimes if the process is hanged, you can kill by the user. Most processes terminate because of completion, errors caused by users or process itself, 2 and 3, or it can be killed by a system or due to a deadlock situations. So I will explain, we have an entire set of sessions for the deadlocks, so we will learn about deadlocks later, or else we actually users can terminate the program itself. So what is a hierarchy? So when one process creates another process, then I told you there can be a parent-child relationship. So when in Unix system, Unix or Linux system, when a process creates a sub-process or a different process, so it creates a process group. So related, one process creates another. So those two are related. So some activity, keyboard activity is conveyed to all. An individual process can execute or disregard the keyboard signal. So KB is that. So Unix process cannot disown its children. That means when one creates a child, so the parent is always there, right? In a Unix. But in Windows, no process hierarchy. So when you create another process, it is independent, right? So the hierarchy is equal. So maybe a special tagging or token can be given to associate one process to another after creation, but all processes are created equal in the Windows, right? So, however, after Windows 7 and 10, there is a concept called process tree came up. So some processes now considered not entirely independent, but it can be related. So when you create a particular process, a main process, there can be sub processes also. This is after Windows 7 and Windows 10, and the concept of process tree came up. When you kill a tree, so the entire set of processes will be terminated. So this is very important, and so many questions being asked in this particular area. to discuss about the state of a process. Actually, there are, I mean, three major states, but in addition, we say 5 states are existing. But 3 major states are these 3. The ready means when each process is ready, it has all the resources for it to run, but it has not got CPU. Then we call it ready state. So I am ready to execute in the CPU, but still I haven't got the CPU time. Then when it is allocated to the CPU, we call a process is at the running state, right? Then when the process is running, when there is a higher priority process comes and trying to access the CPU, the CPU can simply put that running process into the ready state because it has to run a priority process. So the always running, the running process can be put back into the ready state, and it may be in the waiting state, right? And otherwise, when a running one may be waiting for an input of a reading a file or waiting for some other process to complete its output, then it cannot run in the CPU. So we put it into the block state because it cannot continue without getting an input from another operation. So we call it block state. So when then we move the running process into the block state, and block 1 will be put back into the ready state when that particular output or input is obtained, but no CPU time was given. So we put back that into the ready state until we get the CPU again. So these 3 states are there, and the transition of the processes are sort of 5 transitions. So when you create a new process, it will be put on to the ready state. When it is allocated the CPU, it will be in the running state. When it is interrupted to run a higher priority job, maybe then it can be put back into the ready state. Or after completing a job, it can exit or end. It can be put into the terminate state, or else when it is waiting for some other input or waiting for some other operation to complete, it can be placed onto the waiting state from the running state. And with that waiting is over, input or output operation, it can be there in the ready state, right? This is called 5-state process transition diagram, and there are keywords associated with this. So that we have to learn because these keywords are important. So when I have asked you to draw a process state transition diagram, this is the diagram you have to produce at the examination, right? So the allowable transitions are different from different state to another state. So these are those. Dispatch, these are the keywords. So dispatch means when we are having a ready state process and we put that into a running state, we call it dispatch, right? Then when the timer run out, that means if you allocate a particular time for a process to run and that particular time is over and the CPU is handed back to a different process, we call it timer run out. And then the changing the running process is put back into the ready state because it has all the resources, but it only doesn't have CPU. Then we have another keyword called block. That means the running process is put back into the block process. Maybe it is waiting for input output or waiting for output from another process. And wake up is from changing from block state to the ready state where it is ready to run. So only the state transition initiated by the process is block. All others initiated by the external parties. Because block means it's a waiting. So it is waiting. So because of that, block is the only transition that can be executed by the process. Others all executed by the scheduler executed by the CPU, right? Likewise, by the outside parties. So this is actually uh, the process transition stuff. So for the moment, because of the sudden nature of the, I mean, scheduling of this timetable, so I have to, go for a different meeting today at 3 o'clock. So I will wind up the day school now, and we will have a full day school from the next one onwards. And I will, by that time, maybe your registrations may have already happened. We don't know still, but we will wait patiently and we will follow the timetable. And I will share the day school link that I have shared is same for all the day schools. So I am not circulating any day schools. Please ask your friends to, join the Telegram group. I will send the notifications there, and you can post anything there related to the class. So, and thank you very much for joining. And we will have this second day school, full day school from this point onwards. I will share the recording. Only I will send you an email, and I will also send you, I put the link in the Telegram group, right?
Excuse me, sir.
Yes.
Sir, in the evening we don't have a class then session.
No. Actually, today I'm winding up the class now, right?
Okay,
Okay,
sir. Thank you.
right. So I will
Sir,
share. I will share
excuse me.
everything in the Telegram group, and I will send the presentation also, and I will email you the
Sir,
Yes. Any questions? Yes.
yes, sir. Then next day school will be held on 24th of July,
Yes.
according to the master timetable.
24th. Yeah. Yes. Yes.
At the
Yes, if
time,
there is a timetable change, you will be informed. That is why I am telling you this. Please be joining this particular Telegram group because there are so many students which I think haven't seen my email also. That is why I have to run for the meeting now, please. Therefore, I'm going to wind up now. But you can ask any questions over the Telegram group, and I'm happy to, report, help you out. I will post everything. I will send you emails also, right? Okay. So
Thank you, sir.
yeah, you're welcome.
Thank you,
So,
sir.
right.
Thank you, sir.
Thank you, sir.
Thank you, sir.